So now on to problem 414G. What is the distribution of n equal n1 plus n2? So what we want to find here is, well, let n be equal to n1 plus n2. Then we want to find the distribution of n, meaning that we want to find the probability that n is equal to 0. We want to find the probability that n is equal to 1. We want to find the probability that n is equal to 2, and we want to find the probability that n is equal to 3, and lastly, we want to find the probability that n is equal to 4. Now, does it make any sense to consider the probability of n being anything else? Well, it doesn't really make any sense, right? Because n1 and n2 range from 0 to 2, so the smallest value of their sum would be 0, and the biggest possible value of their sum would be 4. So how do we do this? Well, the way we do this is we consider when n is equal to 0. So what do n1 and n2 have to be for n to be equal to 0? Well, n is equal to 0 if and only if n1 is 0 and n2 is equal to 0, right? So when is n equal to 1? Well, there are two cases. Either n1 is equal to 1 and n2 is equal to 0, or n1 is equal to 0 and n2 is equal to 1. And so continues this calculation, because for the probability of n being equal to 2, we see that happens for this case, and this case. Hence, the probability that n is equal to 2 is equal to the sum of these three probabilities. And the probability that n is equal to 3 is given by the sum of these two probabilities, and so on. So what we notice here, first of all, is we cannot use the convolution formula. First of all, it's not that relevant for us here because, well, we do have the joint probability. And secondly, because the convolution formula from the book needs n1 and n2 to be independent, which they are not. So let's take a look at the answers in Excel. So what we see here, you can see how I have calculated the different probabilities of n. So the probability that n is equal to 0 is just 0.8. The probability that n is equal to 1 is the sum of these two cases, and the probability that n is equal to 2 is the sum of the probability in these three cases, and probability of n being equal to 3, and the probability of n being equal to 4. So that was the end of exercise 414, which is long and filled with calculations. But again, sometimes it's really, really good to get in contact with the real numbers. There are also certain things that we can consider when we see these numbers. First of all, the correlation, for example. There's a positive correlation between n1 and n2. What does that mean? Well, that means that we expect to see that if we observe a higher value of n1, then we expect to see a higher value of n2 compared to if we had seen a lower value of n1. So that's how we can interpret correlation. And also, apart from that, you can think a little bit about how these conditional probabilities kind of work. You can try to think a little bit about them, about the size of them. And why is it that when we condition with a greater set here, then this probability grows compared to when we only condition on n2 equals 1? Is that always the case? Is it only because we have exactly this table? So when we have these numerical examples, it kind of helps you widen your horizon of curiosity. If there are certain things that you can't understand theoretically, it often helps to make a numerical example. And so this was problem 414. Thank you for following. Those of you who are still waiting for problem 417, it will not be uploaded this week. Kind of feel like We need to see people solve it first before I know what to upload for problem 417. So this will be it for this week. Have a nice weekend, you guys. Cheers.